Yeah.
Thank you, ma'am. So very good evening to all the participants. This is day 5 and the lab session folder is already shared with you. You can access the content of today's lab session through this particular drive, which you have already accessing from last 3 days. So this is the neural network complete notebook, which we are going through. This other two are the data set, train and test data set. One by one, we will have the detailed description of these things. Meanwhile, I request you to please download these 3 files and upload it in your drive. So I request you please download train.csv, test.csv, and this classification using neural network. So we'll start with a brief introduction to AI as a service. And then we will go ahead with the hands-on session on classification using neural network. The recent advancement in the area of cloud computing is AI as a service, where various services. Ma'am, your mic is open now. So in AI as a service, the cloud service provider gives us the services such as platforms, deployment, and running your AI applications. Some of the example of AI as a service are the very well-known ChatGPT. From day one, you are like listening about what is ChatGPT. The second is Google Cloud API. One of the sub part of Google Cloud API, you can say, is Google Collaboratory. Other than that, you have Amazon AI and Microsoft Azure AI. Any of the AI-based application you can use to deploy your application or to create a new application using these services. So I think all of you are able to upload the data. Let us go ahead towards the implementation part. So I request you to please create a folder in your drive, and then you have to upload 2 things. One is this train.csv file, and one is test.csv file, which we have shared with you. It is in day 5 folder of artificial intelligence and machine learning, this particular folder. Please download these 2 files, train.csv, test.csv. I'll explain what these files have. And then you have to upload these files. If you are able to like upload these files, please let us know. Or if you are facing any issue, then also you can write it in the chat box. Download these 2 files, train.csv, test.csv, from the shared folder. Upload it anywhere in your drive. So I think now you are able to upload it. Let's go ahead with the, okay, you have uploaded. So what I'm doing, I'm creating a new Python notebook here in this folder. I have created one folder, day 5, inside it, practice. So I'm creating a new notebook. From this plus new sign or menu, I'm going to more. And here you can see option Google Collaboratory is there for me. If you are not able to find Google Collaboratory here in more option, you can if Google Collaboratory is not there for you, you can go to this plus connect more apps. So here you can search for Google Collaboratory. This is the Collaboratory. You can install this to your drive. In my case, it is already installed. You can install it. After installation, you will get plus new, more, and then Google Collaboratory will be there. So in the practice folder, one new file is now created named as untitled. You can rename it. I'm renaming it as ANN classification. So this is the Google Collaboratory environment on which you are working from your very first lab session. The services provided by Google Collaboratory for AI as a services, they provide you CPU, GPU, and TPU environment. The by default environment on which you are working is the CPU. Other than that, when you will go to this runtime option, then you will find that change runtime type is there. Here you will have hardware accelerator. So none is for CPU. If you want to use GPU for your large size data sets such as images or text, then you can go ahead with GPU or TPU option. GPU is graphics processing unit, TPU is tensor processing unit. So it will provide you the background support of these GPUs or TPUs from the Google Cloud service. So I'm not setting GPU or TPU. Let's work with only basic CPU environment. Now I will connect to the cloud. So in between, if you have any issue, you can write it in the chat box. We will try to help you. The next thing is to access the data from the Google Drive. You have already uploaded the data set. Now we will explain what is our objective and then we will read the data. So the data set we are going to use is human activity recognition smartphone data set. In today's scenario, all of us has the access to our smartphones or mobiles, which has a number of sensors like light sensor, temperature, gravity, proximity, gyrometer, and accelerometer. Data is collected from these sensors, and based on these sensor, the activity recognition or other type of task is performed by your smartphone. So there are two basic sensors, accelerometer, and other than that is gyrometer. These sensors are used to identify or collect the data related to human activity. So today's task is based on these data, we have to identify the activity of a person. So for this particular task, this is the data set where there are total 10,299 instances or rows and total 561 columns, or you can say these are the feature vectors. 561 feature vectors are there, which are collected through accelerometer and gyrometer. These are the time and frequency domain features. Our objective is to classify these data based on the features into 6 categories. So the categories are whether a person is walking upstairs, walking downstairs, whether he or she is sitting, standing, or laying. These are the 6 activities which you have to classify through a basic neural network architecture. You can go through this particular link to access the data. That link is already with you in the shared Python notebook, as well as just now we have copied the link to the chat box as well. Next is to access the data. We have downloaded the data, then it is there in the CSV format. One is train.csv, one is test.csv. Now we have to read the data from the drive. So for that, you have to mount or connect this Google Collaboratory to your drive. So for that, you have to click on this particular icon. You can see in the left side of the panel, one folder is there. Click on that panel. Then you will find on the top menu, Mount Drive option is there. Click on that. It will ask you for the permission. When you allow this particular drive, this particular notebook to access the drive, then a new folder will be created here named as Drive. So you can see a new folder is there, Drive, My Drive. So now I will navigate to the place where I have uploaded train.csv and test.csv. Similarly, you have to go to your drive, go to Drive, then My Drive, and go to the place where you have uploaded the train.csv and test.csv. In day 5, I have uploaded these files in practice folder. You can see train.csv is there, test.csv is there, and this notebook, AI&ML classification is there. So I'm copying, copy path, by right clicking on the practice folder or on these 3 dots. I'm just copying the path, and then I'm writing cd, that is change directory command, to change the current working directory to the place where our data, the CSV files are present. Now, as this Google Collaboratory is based on the cloud environment that has Linux environment or Linux operating system, so all the commands which have whichever work on the Linux environment will also work here. So other than cd, now we will use ls command to list the files and directories in the current working directory. So you can see the train.csv file and test.csv file is with us. You have to change the current working directory using cd command, and then you have to check whether train.csv and test.csv are there or not. I'm giving you a minute so that you can do the same. If there is any issue, please write it in the chat box. So I think all of you are able to now access the in.csv and test.csv to your current working directory. The next task is read these 2 files, train.csv and test.csv. So in the earlier labs, you must have used pandas package to access the or read the CSV files. The same package we will use here. Import pandas as PD. Then we will read train data frame using pd.read CSV. And here you have to provide the path of your train CSV file. So train.csv. traindf.head to plot or to show the top 5 rows of the train.csv file. So you can see there are 5 rows which we are displaying, and total number of columns are 563. But when you'll go to this particular data set, you will find out the number of attributes are 561. But here we have 563 columns. So what are the other columns? Let me tell you. These are the initial 561 columns are time and frequency domain data or features which are already normalized. You can see all the data is within range of -1 to 1. So no need to normalize the data. The last two column, one is subject, is the person or on which the this particular sensor collection, data collection is performed, and one is activity, that is your target class. So we have total 6 activities: standing, walking upstairs, downstairs, laying, and sitting. So up to this particular column, is column number 561, we have the input vectors or input features. This particular column is of no use, as we don't, this is not, everywhere you will find out that subject is one only, because at a time one person is used to one subject to person is data is collected, and this is the output or label. So after reading in this CSV file, now we will read the test data as well with the same code, testdf td dot read CSV test dot CSV, and then test df dot head. Again, it will have the same number of columns, that is 563. I think up to this part you are able to do. So after reading the data from CSV file, next step is separating the data into input and output. Output is your label. So let's, first of all, from train data frame, read the input vector. Input vector is total 561 columns and the number of rows present in the train data frame. So for that, we are creating a variable X, from where, from train data frame, we will drop the last 2 columns, that is activity and subject. So other from 563, if you will drop last 2 columns, you will have only 561 columns, which will be your input or feature. Train data frame dot drop columns will be, first column is, I think first column is subject, and then the second column is the activity, that is your output class. And in the Y or the output variable, you will have from train data frame, you will only have one column, that is activity. In the same way, you have to read the data from test.csv. So test.data, test_df. So we will have test that will be reading data from test.df. Other part will be same. Then we will have y_test that will be reading data from test data frame. So till this part, what we have done, we have accessed the data through our Google Drive, separated the data into input and output vector. Now, generally, we split the data into 3 parts: training, validation, and testing. So training data is to train your model or algorithm. The validation data is used to validate the performance of the model after each epoch, or you can say once the complete train data is fitted or back propagation is performed over once over all the train data, then we evaluate the performance of the model using validation data. So after each epoch, we will have the validation data for performance evaluation. When your model is completely trained, maybe for 100 times, 10 times, or 50 times, it depends on you. When the training is completed, then you generally use your test data to finally evaluate the performance of the model. So here also we are doing the same concept. Earlier you have split your data into train and test. Now we will split the data into train, validation, and testing. So testing is already there in separate file, that is test.csv. So now we will split the train data frame to train and validation. So the split will be performed using sklearn's train test split function. From sklearn.model selection, we are going to import train test split function. So this train test split function, you have already used this. It will take the input. So suppose we are providing two input, X and Y. So it will split these two input into 4 outputs. You have to provide the test size. So let us split it into 80-20 ratio. So I am providing test size to 0.2. It will give us 4 output. So let's store the output into 4 variable. X will be having X train and X validation. Similarly, Y will have Y train and Y validation. So this is the way through which you are splitting your train.csv data or train data frame into 2 parts, training and validation. So can you respond on the chat if you are able to do till this part? In between, if you find anything difficult or any error is there, you can write in the chat box. So after splitting the data into training, validation, and testing, next is our Y. When you read the Y output, it is having the text values, that is standing, sitting, walking, laying. So what we have to do in place of these in place of these variables, or you can say these string, we have to replace these activities to some integer value. That is known as label encoding, where we will replace each activity or each output class to a corresponding label. For example, if there are 2 classes, maybe cat and dog, so you can assign cat as 0 and dog as 1. Similarly, here we have some 6 classes. So it will be starting from 0 and till 5, you will assign each class a particular label. So for that, we have in sklearn various pre-processing steps are involved present. So we are going to use sklearn only to perform this label encoding task. So from sklearn, we are going to import pre-processing. Using this pre-processing function, this pre-processing step, we are going to call label encoder. Label encoder. So it will call one object of label encoder. Using this particular object, now we will call the fit transform. This thing I think you have used in some other way earlier, like min-max scalar or standard scalar. The same way we are using label encoder. So fit transform. Here you have to pass your y variable, that is y train. We have 3 such variables. And I'm storing it into y train encoded. Similarly, we will do the label encoding for validation data. And then for the test data. So this is the way through which we are performing the label encoding, converting the text to the integer. So till this part, we have done data reading and data pre-processing. Our next part is model building or creating a neural network model. So for that, we are going to use Keras API of Python, which is a high-end API to develop any type of neural network, whether it is ANN, CNN, RNN. So you can use Keras for that. Various predefined layers, functions, and the metrics are there, which you can use. Other than Keras, you can use TensorFlow, which the Keras is developed on the top of TensorFlow. So the backend is TensorFlow only for Keras. And other than Keras and TensorFlow, you can also use PyTorch for your neural network development. So let's go ahead with the model development. So we will start with a basic hidden layer neural network. And then we will try to increase the number of neurons, number of hidden layers to check how the performance is changing. So any one of you can tell in the chat box what will be the size of your input vector to the neural network? Anyone in the chat box? What will be the size of your input vector? Before creating what? How many features are there in our data set? Anyone? Till now, I didn't get any correct answer. What are the size of the feature? Tell me in the form of integer. Okay, so 561 features are there in your data. So in your input layer, you will have total number of neurons as 561. The next is the first hidden layer. So first hidden layer, the number of neurons in the hidden layer is a hyperparameter. It depends on you. You can try with 16, 64, 32, 100, whatever you want to set. So for this particular example, we are setting number of neurons in the first hidden layer as 64. As explained by Parth Pratim Roy sir, to calculate the number of parameters, what you have to do, you have to calculate the number of elements in your weight matrix as well as number of biases. The total number of elements in the weight matrix plus the total number of elements in your bias will be the parameter in a particular layer. So you have to tell me what will be the size of weight matrix here. In the first hidden layer, what will be the size of the weight matrix? The concept you know, W1x1 plus W2x2 plus W3x3 up to Wn(xn) as explained by sir. So what will be the size of the weight matrix here? How many times W1x1 will? So we have total 561 neurons here in the input layer. In the first hidden layer, we have 64 neurons. So the number of times the weight matrix will be 561 cross 64 because the first neuron of the input layer will be multiplied by the 64 neurons. Second neuron will be again multiplied to the 64 neurons. Like that, the size will be 561 cross 64. This will be the size of the weight matrix. And what will be the size of your bias? How many bias will be there? So total you will have 64 biases. So your weight matrix will be of size 561 cross 64. Total 64 biases will be there. So total number of elements will be 561 into 64 plus 64. So 35,968 total trainable parameters will be there as explained by sir earlier. So let's go ahead to the second hidden layer. There can be any number of hidden layers. It depends on you because it's a hyperparameter. The number of neurons are again depends on you. There is no such rule that you have to use that like whether the if you will increase the number of layers, neurons will also increase. You can try with any combination. So in the second hidden layer, we are taking total 16 neurons. So here I think now you can calculate what will be the weight matrix size and what will be the biases. So in the second hidden layer, we will have the weight matrix of size 64 cross 16 and the biases will be 16. For each neuron in the second hidden layer, you will have one bias. So total 1040 parameters will be there in the second hidden layer. Now we will have output layer. So there are total 6 activities. That means you have 6 classes. So that's why the output layer will be having 6 neurons. In place of 6, suppose you have to classify the data into 10 categories. The output layer will have 10 neurons. So here the weight matrix will be of size 16 cross 6. The biases will be 6. Total number of parameters will be 16 into 6 plus 6, that is 102. So the total number of parameters here in ANN will be 37,110. So now our objective is to deploy this particular neural network to Keras. We will have 2 hidden layers, one input layer, one output layer. First hidden layer will have 64 neurons. The second hidden layer will have 16 neurons. And later we will modify this structure. So to access the Keras, you have to write from TensorFlow. You can import Keras. So in Keras, there are 2 types of models building capabilities available. One is the sequential model, one is functional API based model. The sequential model is the model which takes single input and provides single output. If you want your model should have multiple input and multiple output capabilities. So in place of sequential model, you can go ahead with the functional API based model. So here we are creating the model using sequential one, and in the upcoming labs, we will also use functional API based model. So from Keras dot models, we are going to use sequential. In place of sequential, if you will write model, then it will be functional API based model. So I request you to please write to everyone who asked the question so that we can help you. The number of hidden layers and number of neurons in a particular hidden layers are hyperparameters. It depends on you. You have to try with multiple combination. Select the best one for your application. So from keras.models.sequential, we are creating a blank model. And next is we are going to add layers in this particular model. So to add layer, you have to use model.add. Add function is there. So model.add. And now you can add the layers. So the very first layer was input layer. So from keras.layers, we will using input layer. In input layer, you have to provide the shape. So whatever will be the feature vector size of your data, that will be the shape of your input. So in our case, we have 561 features, input features. So we are writing 561 comma, because if you will write only 561, it will consider it as a constant, not array, not in the form of an array. So this is our input layer. Next is the first hidden layer. So in first hidden layer, you have some 64 neurons. So model.add from keras.layers, the ANN layer that the layers which you use to deploy ANN is named as dense, that because these are densely connected layers. So that's why dense layer is there in the keras. So you have to use that particular function dense. Here you have to provide the first parameter is the number of neurons, that is units. So let's use 64. Earlier in the PPT also we had used the same number of units. And then the second thing is you have to provide activation function. The activation function was already explained by Sir in the first session. So activation is in hidden layers, generally ReLU, leaky ReLU are used. Nowadays, leaky ReLU is used. Earlier, the researchers were using ReLU for the activation in hidden layers. So this is our first hidden layer. In the second hidden layer, we had 16 neurons. And then next is the output layer. So in the output layer, there will be only 6 neurons because there are 6 classes in our data. And again, the activation function will change here. Because we are classifying the data into various categories. So other than ReLU or leaky ReLU or sigmoid, there is one activation function exists, that is softmax. So softmax give you the probability for all the 6 classes, because there are 6 neurons. For each neuron, it will give you one probability. Based on that particular probability, your data will belongs to that particular class or neuron. So this is the structure of the model that you have earlier like imagined with 4 layers. First is the input layer. This is the input layer. These two are the hidden layers, and this is our output layer. Now, let us check the summary of our model. So 35968, 1040 and 102. Total parameters are here. So this is the way you can create a simple 2 hidden layer based neural network. I have pasted the code in the chat box. I'm giving you some time so that you can also run the same code. This part, if you have any issue while writing the code, please let us know in the chat box. You can write to everyone. So here you can see our data is already in one dimension, 16, 60, 64, 16, and 6. So no, we need to convert into one dimension. Layers.flatten is a layer that is used to convert your multidimensional data into single dimension. So here no need to use a flatten layer. When you will work with multidimension data, then you will use the flatten layer, maybe for images or other time series based data. How to add new data value in the same data. Deepti ma'am, can you please elaborate your question? I'm not getting it. So if you want to update data, existing data, you have to, like, initially you have to provide the updated data only na, for training. If you have the data, two data sets are there, you want to merge them or update them, you can like read one data in a single variable, the second data will be read into second variable, and then merge both the variables to update the data. So you are getting error that TensorFlow is not there, no module TensorFlow. If you are working offline in your system and you have GPU available in your system, then you have to, instead of pip install TensorFlow, you have to install pip install TensorFlow -GPU. So make sure your hardware is like you are installing the compatible package with your hardware. So if you are getting the error, no attribute input layers, so please remove S from input layers. It's input layer. Check the syntax properly. So can we go ahead now? Till this part, you have done data reading and pre-processing and then model building. Now your objective is to train your model through the data you have read and pre-processed. So the very first step before training the model is model compilation, where you have to set some parameters for your training for compilation. Such it generally takes 3 basic arguments for compilation. The very first is the optimizer. So I think in the theory parts, you have not completed the optimizer one. So optimizer is the algorithm which helps you to optimize or to update the weights in a particular way that the learning will, your neural network will learn better. Next is the loss function, which you are going to use. So your neural network will learn that particular loss function. And the third parameter is the matrix, on which you are going to calculate the performance of your algorithm. So let's compile the model, model.compile. The first one is the optimizer. So in Keras, we have optimizers. You can go ahead with the keras.io website to go through all the facilities available in Keras. So you can see in optimizers, we have various optimizers available such as RMS Prop, SGD, ADAM, NADAM. So here we are going to use ADAM as an optimizer. And then you have already talked about learning rate. So we are setting learning rate as 0.0001 for this particular model. Generally,
So,
the learning rate. Yes, ma'am. Yes.
Actually, optimizers, they have not been discussed.
Yes,
This is not. So we will be doing it. Professor Parthpatrim Ray will be doing it tomorrow. So don't worry about it. He will be explaining. Okay. Thank you.
So learning rate, you know that sir has already explained how to learning rate helps you to improve the training. Next is the loss function. So the loss function you have to set is depending on your output vector. Here we are using label that is 0, 1, 2, 3 for each class. So that's why from Keras, there are various losses available. Keras.losses. We are going to use sparse categorical cross entropy loss. So make sure whenever your data is in the form of label encoder like 0, 1, 2, 3, you have to use sparse categorical entropy loss. And then the third one is the matrix which you are going to use to evaluate the performance. So matrix will be, let us use accuracy. So these are the three parameters which you have to pass in model.compile function. After compilation of your model, you have provided the required parameters to train your model, that is optimizer, loss function, and matrix. Now you are good to go for your training. So for training, there is a function fit is available through which you can train your model. So our model name is model. This is the name of the model, model.fit. If your model name is ANN model, then you can write ANN model.fit. The very first parameter that you have to provide is the input for your training, that is xtrain. Then the second variable that you have to provide is the output. So the name of the output is xtrain encoded. So this is input, this is your corresponding output. Then we have to provide the validation data. So validation data is x_val and the corresponding y is y_val_encoded. Other than these these three parameters, the parameters which you have to provide, you can see it is suggesting us. You have to x and y you have already provided. Batch size you have to provide. Epochs you have to provide, and various other options are there. So first of all, let's set epochs. Epochs are the number of times you want to train your model on the complete data set. So there is a slight difference between iteration and epochs. So in epochs, every time the complete data will be there for training. So let us set the epochs as 30. And then other important parameter is batch size. We are setting it as 16. So let me explain what is batch size. Batch size is the number of data points you want to send to your model in a single batch. So every time we are setting it is 16. So 16, 16, every batch will be of size 16. Suppose you will have some 160 elements in your data. So there will be total number of 10 batches. In first batch, 16 will be there, second will be 16. Like that, you will have some 10 batches. When all the 10 batches, after completion of the first batch, your first iteration is completed. Then second batch will be completed. That means your second iteration is completed. Like that, all the 10 batches will be trained on the model. And then wait update process will be performed simultaneously. And then when the complete data will be once shown to your model, that means your one epoch is finished. After the first epoch is finished, your validation data, this XVal and YVal, will be used to evaluate the performance of your model after first epoch. In the same way, remaining 29 epochs will work, and at the end of the 30th epoch, your model will be completely trained. So let us train it, but before training, let me store the intermediate values in a local variable. If everything is okay, then the model training will be started. So you can see it has started the training. The loss has started, the training loss is started with 1.1. The accuracy is initially 62.51%. Validation loss is 0.73 and accuracy is 80.97 for the very first epoch. So you can see this total 368 batches are there. Size of each batch is 16. If your training is perfect, then your loss should decrease, your accuracy should increase for both training and validation data. So at the end of the 30th epoch, you can see the loss is 0.0532. The accuracy is 98% for training. The validation loss is 0.0613. The accuracy is 0.97, or you can say 97.48%. I'm pasting this particular code to the chat box and giving you some time so that you can do the same. When you are done with this training process, please report it in the chat box. 368 is the number of batches. We are setting the batch size as 16. So there will be total number of 368 batches, each of size 16. So we are waiting for your response. When you are done with the training part, please let us know so that we can go ahead with the other part. So the videos are already shared with you. It is live streamed and the link is there in the shared folder.
Poornima, that contains yesterday's Google Colab book also, right?
Yes, ma'am. It is there in the shared
I was asking, somebody is writing. Yeah.
Yes, ma'am. It is there.
Okay.
This is the file, kmeans.com.
Yeah. So Durgesh, can you please once again share the link?
It is shared in the beginning.
So those who do not, who join later, they don't get the link. So
okay, I'm sending them.
okay, thank you.
So I've shared the link.
So till this part, you have done training of the model. The next part is we have performed the total 30 times or 30 epochs for training. So let us check what is the pattern, how your model is trained after or learn the features after each epoch. So for that, we will plot the graph for each epoch for loss as well as accuracy on training and validation dataset. The plotting will be done by basic package, that is matplotlib. So we are using import matplotlib.pyplot is plt. Then to access the epoch-wise performance, we have stored the data in this model underscore history variable. We are going to use it, model underscore history. So it will have another variable named as history, where you will have, it is a type of dictionary. There you will have the data in accuracy. I think this is the accuracy we have used. So the name of your matrix here you are using should be same as here. So this is our train accuracy. In the same manner, you can access the validation accuracy. So number of epochs will be the range. You have to provide it in the form of range, so that it will start from 0 to up to 29. Length of your train accuracy. That will be 30 only. You can manually write 30. Next is we will plot it. So plt dot plot. The first parameter will be your x-axis, that is epochs, and corresponding y-axis will be our train accuracy. So you can see, we will modify this particular graph. Till now, what we have done, we have provided x-axis from 0 to 29, that is up to 30, that means 30 epochs. And on the y-axis, you have provided the epoch-wise accuracy. Now next is you have to provide validation accuracy. So another line will be there, this orange one. This is for validation. So you can see initially for the very first epoch, the training accuracy was nearby some 60 to 63%. And the validation accuracy was some 81 or 81%. And then after some time here, you can see they have crossed each other. Now the training accuracy is more and validation accuracy is little less. So you can say this is the portion where your training is almost completed. Next is you can provide labels to these particular graphs. So I'm providing label as training accuracy. And then our validation accuracy is this. You can provide title to your plot, plt.plot, and then, sorry, plt.title. Title. And this is our training and validation accuracy graph. And you can provide legend to your graph. And then plt dot figure or plt dot show you can use. So you can see training and validation accuracy is the title, and this is the color wise legend to your. Similarly, you can provide the axis, x-axis and y-axis. In the same way, you can plot the loss graph also. Validation loss. So this is our loss graph. If your data is correct, your model is working fine, then your loss should decrease after each epoch. And when you will find out that the your curve has flattened, that means you are getting a straight line. At that time, your training is finished. So you can stop your training at that particular time. So there are various options available for that. One is the early stopping. Through that, you can control the number of epochs. Instead of 30 epochs, you can stop the training at maybe 25 or 20th epoch. So you can go ahead with the rs.io website if you want to use those facilities.
आप ना मैम हमने लॉगिन किया तो हमें तो कुछ दिखाई नहीं रहा है वो पेपर
मैम
शुभांगी वाला
So all of you please do this particular part, because whenever you are working for any type of research problem, these are the basic graphs you have to show in your research paper. So after training the data, we have evaluated the performance on validation data set after each epoch. The next part is to evaluate the performance on test data. Because your test data is not used while training or validation, it is a separate data set. That means you have to report the performance of your test data whenever you are working on a research problem or any type of application. The test data is the performance of the test data is generally reported. So for that, evaluate function is there. So name of the model dot evaluate. And here you have to provide your trace data and corresponding. This is your X test and X underscore test, and this is your Y test. And corresponding label. So it will give you two matrix. One is the loss and one is the accuracy. So you can see for this particular model, you are getting the testing loss as 0.1707, and then the accuracy is 93.52. So this is the accuracy loss on test data set. Generally, the performance on the test data is little lower than the accuracy or performance on the training and validation data set. Next part is when your training is completed, you have tested your model, you want to use the same model later on. Maybe you have developed a model for your mobile based application to predict or to like face recognition task, or to identify the position, like here human activity recognition. You have trained this particular your model you have created and trained. Now you want to deploy the model on your mobile to identify based on these features from the gyrometer and accelerometer. You want to predict what is the position. So like your model will give maybe 90 to 93% of the times your model will predict correctly that a person is maybe sitting or standing or walking upstairs or downstairs, like that. It will predict correctly, maybe up to 93% of the time. So for predicting on unknown data, till now you had, every time you have passed the input data and corresponding vectors. But when you deploy the model on mobile device or anywhere else, at that time you don't have the corresponding label with you. So there you have to use predict, where you will have only input vectors. So you have to pass 561 input features to your model, and it will predict the class of your person or whosoever is using that particular mobile phone. So for that, you have predict option available. So instead of creating a new data set, because creating a data set of 561 elements or features is quite difficult, and arranging it to a correct form is also difficult for us. So instead of creating a new data set, we are selecting the first row of your test data, only the input, and then we will calculate the output and then compare with what is the actual output and what is the predicted one. So we have the data in this X test. From X test, we will, through ilog, we will access the very first row. So first row and all the columns. This is our test data. So now let us check what is the shape of this particular data. It should be 561. So you can see it is 561. Now we have to pass this data to our model. So let me first run it. It will give us error because it is 561. So it will consider it as maybe instead of, it will consider it as list. So we have to convert the type, that we will do later. Let me show what is the error it is giving us. So model.predict, and then I'm directly passing the data. So you can see what it is giving, that you are passing the shape as none, comma 1. This should be the shape, but our shape is only 561. That is, it is treating it as a single dimensional array. So for this, what you have to do, you have to reshape this. So for reshaping, we are going to use numpy array, numpy package, import numpy as np. Test data. First of all, we have to convert it to numpy array. And then we will reshape it. So what will be the shape? Shape will be 1, 561. So now it has predicted something. We will store it to ypred variable. Now we have the result in ypred. But when you print the value of ypred, you will see that it is giving you some probability. In this is the very first class probability, second class probability. This is the probability it will belongs to the third class. If you will start with 0, so it's 0th class, first class, and then second class. So from this particular sample, you can see that it is predicting it to class 2. If you will start with 0, 1, 2. So it is predicted in class 2. But to know the highest index, you can use np.argmax. And then you have to pass the probability. So it will give you the maximum index. So it is saying that it is from class 2. So now let us see what was the actual class. We have the output in this Y test encoded. From Y test encoded, the 0th value was 2. So this is the way you can deploy your model on a real world scenario or mobile phone for real-time prediction. This is just for telling you that the output is correct. So when you want to use your model on a new device or on real world scenario, you want the trained model. You cannot do the training on a mobile phone. So to access the trained model, you must have saved the model somewhere. So for saving the model, there is a function, name of the model.save, through which you can save the model. So I'm saving model.save. And here we are passing model ANN.h5. So generally it stored the data in the form of SDF5. I mean distributed file system. It will store the data. So I'm saving it. So it will store the H5 file here in my practice folder. It will take some time to reflect in your drive. You can see this is model_ANN.h5, which is created from here. This is the way you can save your model. Then again, to read the model, what you have to do? Suppose you want to access this saved model somewhere in other maybe laptop or other mobile phone. Then you can save it. You can read it like this, ANN model. I'm creating a new model, ANN model. And then from cares.models.load model function. And then you have to pass the path of the saved model. This is the way through which you can read the saved model. So this saved model will have the structure of your model as well as the trained weights. So instead of model, if we will use ANN model.evaluate, then also you will get the same performance. So let me pass the 93.52 and 0.1707 was the performance earlier. So after loading the model in a new place, you are getting the same performance. So this is the way through which you can save your model after training with model structure as well as weights, and then load the model. There is another way of saving the model weights only, not the structure. So whenever you want to save only weights, maybe intermediate training where you don't have so many of resources and you want to only save the partial weights every time, maybe after each epoch. So at that time, instead of saving the entire model, we save the weights and update the weights after each epoch. So to save the partial weights or to save the weights at the end of the model training, save weights function is there. So model.save_weights and then ANN model weights.h5 I'm creating. But this time you will save only weights. You cannot save the structure of the model. So if you want to use these weights, you have to create the complete model from that earlier, like Keras dot models dot sequential and then model dot add layers. The number of layers and the number of neurons should be same as in the weights file. Then only you can read this weights. That means you can read the weights in AI&ML model as well as this model. So to read the weights, what you have to do? AI&ML model dot load weights and then provide the path of weight file. Again, if you want to evaluate the performance after loading the weight, then also we'll get the same performance. So I think up to this part, all of you are able to understand how to work with artificial neural network, how to pre-process your data, create your sequential model, compile your model, training, and then evaluate the performance of the model in the using the unknown or test data set. So earlier what we have done, we have created a very small model with only 2 hidden layers. And we were getting the accuracy as something 93.12%. But if you want to create, like add more layers to your neural network, you can do that too. For example, in the first hidden layer, now earlier we had some 64 neurons. Now you can increase it. Instead of 64, I'm using 128. And then I'm adding the second hidden layer, 64 neurons, then third hidden layer with 32 neurons. This is not a rule that you have to decrease the number of neurons after each layer. This is just for experimental purpose. So now what we have done, we have created a model with 4 hidden layers, 1 input layer and 1 output layer. This time your number of neurons, because your number of neurons and number of hidden layers has increased, so your number of parameter will also increase. So you can see this time we have some 82,902 new parameters. Other process will be same. You have to compile the model. Then you have to train the model. After training, you can plot the loss graph. And then you can evaluate the model or predict the test accuracy and loss. You can calculate that. It will take some time. Let us see what are the changes in the performance when you increase the number of layers and number of neurons. Earlier we were getting accuracy as I think 93.52% and 0.1707. Now see what is the changes. What are the changes we are going through? It is about to finish. So this time the training is a little bit like validation graph is fluctuating a lot. So you are getting little less accuracy. So again, you have to try to adjust the number of layers, number of units, then maybe your performance will again change. So I'm using 256, 128, 64, and 32 this time to see whether I'm getting accuracy more than 93% or not. So this is the way through which you can update your model structure. So I think we have some 4-5 minutes more. So let us discuss one more thing. That is the classification report that will show you the precision, recall, and F1 score for class-wise performance. Meanwhile, it is running. So in sklearn, you have classification report as well as confusion matrix available. You can use that from sklearn matrix. We are going to import classification report, and we will use this classification report to plot the class-wise precision, recall, and F1 score. Model.predict. Here we have to pass our test data. So you can see this time our accuracy is higher, that is 94.40. So you have to try with different combination for your model to select the best one. So this is our by predict. Model will predict. Then we will calculate by predict class and creating a list to store the intermediate values for I in ypred. We have some predictions in ypred. And then we will store the class in ypred.class because ypred have the probability. So earlier we have used argmax. So we will use argmax, i.argmax. And then we will print the classification report. Here you have to pass the predicted class in the classification report, and similarly you have to pass the actual class. And then it will give you the class wise and total precision, recall, and F1 score. So you can see for 0th class, the precision was 111, precision, recall, and F1 score. Total 538 samples are, so for the test data set, total 538 samples are there for class 0. For class 1, out of 517 elements or rows, 94 is the precision, 90 is the recall, and 92 is the F1 score. And this is the overall precision, recall, and F1 score for all the 2,947 samples from the test data set. So I'm stopping here. If you have any doubt, you can let us know in the chat box. And this particular notebook is already shared with you in the day 5 folder.
Still, there are a couple of questions, Poornima. You
Yes.
can take up those questions before we end.
So first of all, the question is about overfitting and underfitting. So it depends on your data and model, how your model will be underfitted or overfitted. I think sir will discuss about it in like tomorrow's session.
Yeah, so a couple of things you will actually, we have another lecture of Professor Partha Pratim Roy tomorrow. So a couple of things will be clear after that lecture. So please, wait for a while.
Yes, the changing number of neurons are the changing the hyperparameter. Number of neurons in a particular hidden layer, the number of hidden layers, what will be the optimizer, what will be the learning rate. Those are all are the hyperparameters.
You can see the day 5 folder is there only. I have given you the link. Please look at that. There you are already having day 5 lab session folder.
So there is a question, can we convert the index to class name? Yes, you can do. We had used fit transform earlier to convert the class name to a corresponding index. So you can use inverse transform to convert the predicted index to the actual class name. Ma'am, I think other questions were already.
Yeah. Okay, so I
Thank
can
you.
see that they were doing things with you, and they are asking questions also. That is a good part. So I request all participants, if you are doing it, that's very good. If not, please see the notebook and try to follow it if you are missing any step, because you can learn only by doing the practice. So now I will take this opportunity to thank Poornima, and in fact, this is a proud moment for me that